Mutual inductance of solenoid. What is meant by the term mutual induction? It is a phenomenon of generation of induced EMF in one coil due to varying magnetic flux through the neighboring coil. Or it is the generation of induced EMF in one coil due to varying current through the neighboring coil. Let us get an expression for mutual inductance of solenoid. Look at this diagram. S1 and S2 are the two coaxial solenoids having same length L placed in vacuum medium of absolute permeability mu naught. Both are longer solenoids, so that when current passes, magnetic field inside the solenoid will be uniform throughout. The solenoid S1 is of length L, total number of turns N1, number of turns per unit length small n1, and radius R1. What about solenoid S2? That is also same length L, total number of turns N2, number of turns per unit length small n2, and radius R2. From the diagram it is very clear that R2 is less than R1. S2 solenoid is well within solenoid S1. A current I2 passes through the solenoid S2. Due to this, how much is the magnetic field produced inside S2? Let it be B2. B2 equal to mu naught into N2 into I2. Then what is the magnetic flux produced inside the solenoid S2? That is phi B2, which is B2 into area of each turn of S2, that is pi R2 square. The same is the magnetic flux linked with S1 also. So how much is the magnetic flux linked with S1? Let phi B1 be the magnetic flux per unit turn of the solenoid S1, that is equal to magnetic field B2 into over how much area magnetic field is acting? Pi R2 square area into pi R2 square. So what is the total magnetic flux linked with solenoid S1? That is N1 into phi B1, which is equal to N1 into B2 into pi R2 square. Substituting N1 into phi B1. What is N1? N1 is equal to small n1 into L. What is B2? Mu naught into N2 into I2 into pi R2 square. Let this be equation number 1. Already we know the total magnetic flux linked with S1 is directly proportional to current I2. Due to this current, magnetic field and magnetic flux are linked with S1. So N1 phi B1 is directly proportional to current I2. Or if we remove the proportionality sign with an equal sign, that is equal to a constant into I2. What is that constant? That constant is called mutual inductance. Mutual inductance of what? Mutual inductance of S1 with respect to S2. We write it as M12. Mutual inductance of S1 with respect to S2. Let this be equation number 2. Look at the LHS of 1 and 2, both are same. So equating RHS, we get M12 into I2 is equal to N1 L mu naught N2 I2 pi R2 square. I2 get cancelled out. So the equation will be M12 is equal to mu naught N1 N2 L pi R2 square, which is the expression for mutual inductance of solenoid S1 with respect to solenoid S2. Now let us try to find out an expression for mutual inductance of S2 with respect to S1. For that, look at this diagram. Here, the same solenoids, but through S1 a current I1 is flowing, and S2 is well within the solenoid S1. S2 is within S1. When current I1 flows through S1, a magnetic field B1 is produced, and that magnetic field B1 is associated with S1 also. So how much is the magnetic field produced by S1 due to current I1? Let us write it as B1 equal to mu naught into N1 into I1. N1 is the number of turns per unit length of solenoid S1. Then what is the magnetic flux linked with S2? That is magnetic field into area of each turn of S2. Same magnetic field act in S1 as well as S2, because since the solenoids are longer, magnetic field is imagined to be uniform within the solenoid. Let phi be 2 is the magnetic flux linked with solenoid S2. We know phi B2 is the magnetic flux per unit turn of solenoid S2. Phi B2 equal to B1 into its area of cross section, which is pi R2 square, or that is equal to mu naught N1 I1 into pi R2 square. Then what is the total magnetic flux associated with S2? If N2 is the number of turns, N2 into phi B2, that is equal to N2 into mu naught N1 I1 into pi R2 square. What is N2? N2 is small n2 into L. N2 phi B2 equal to N2 into L. We know small n2 is equal to capital N2 divided by L, total number of turns per unit length, into mu naught N1 I1 into pi r2 square. We'll call this as equation number 3. And as we had seen earlier, this total magnetic flux associated with S2 is directly proportional to current passing through S1, that is I1, or N2 phi B2 is equal to a constant into I1. What is that constant? That is the mutual inductance of S2 with respect to S1, which is M21, mutual inductance of S2 with respect to S1. We call this equation number 4. Now look at the LHS of equation 3 and 4. It's same. So equating RHS, we get M21 into I1 equal to N2 into L mu naught N1 I1 pi R2 square. Out of this I1 get cancelled out. Therefore, M21 equal to mu naught N1 N2 L into pi R2 square, which is the expression for mutual inductance of S2 with respect to S1. Look at the previous case. What is M12? M12 is mu naught N1 N2 L pi R2 square. So from this it is clear that M12 is equal to M21. Mutual inductance of the solenoids are same.